Nobody is responding. Everyone is sleeping.
Good evening, ma'am.
Good evening. So we'll continue our lecture on Z transform. Let's start. So in the last class, we have discussed up to here. Now we want to find the Z transform of Z cos n theta and sin n theta. So we'll find both together using damping rule. So please remember the damping rule because we are going to use it. If un is multiplied by negative power of a, then az. If positive power of a, then z by a. Okay. So that we are going to use. We'll take z e power I minus I and theta, right? You can write it as e power minus I theta into n, power n, right? Now we can use damping rule here, right? Un is this multiplying by positive power of a, where a is, see this, e power minus I theta, and un is 1. Just to make you understand, I am writing this. So for un, we should have uz also, z transform of un. So for 1, z over z minus 1, right? So when un is multiplied by a positive power of a, then it will be replaced by z by a. A is e power minus I theta over z over e power minus I theta minus 1, right? So directly I'll write here. This you can note down in your rough. Okay. So just I'm mentioning here un is 1. So uz is, capital uz is z over z minus 1. That means value of this is z over e power minus I theta, z over e power minus I theta minus 1. Okay, now z over e power minus I theta, z minus e power minus I theta LCM, right? That means we get, so this is the complex number in denominator. So when we have complex number in denominator, we used to multiply by its complex conjugate so that we can remove this complex number from denominator, right? So complex conjugate I'm talking about. So complex conjugate will take for this, not for here. Okay. So we'll multiply by I theta. Because it is minus, so complex conjugate will be plus. Now z into z minus e power I theta. Then z square, z into z, right? Then z into this I theta, then this minus I theta, then this and this. So plus 1. Now e power I theta, you know this, right? E power I theta is Euler's formula, cos theta plus I sin theta. So cos theta minus I sin theta, because minus is outside, Now this minus, take z common, e power I theta plus e power minus I theta, right, plus 1. Now we know that cos theta formula in terms of exponential is e power I theta plus e power minus I theta divided by 2. So this value is 2 cos theta. Z into z minus cos theta minus iz sin theta. We have multiplied this. Z into z minus cos theta and this. Okay. Now see, no complex number, only we have complex number this side in numerator. So we can rewrite this as we can separate the complex and real part, imaginary and real part. Now I want to rewrite this LHS. Cos theta and theta. That means minus n theta. See, e power I theta formula I am using. So minus n theta plus I sine minus n theta. This is your LHS. Now cos minus theta, fourth quadrant positive. That means Z transform of cos and theta. Now sine minus theta minus sine theta because it is an odd function. Now because we have read the linearity property, so we can write this as Z transform of cos and theta minus I into Z transform of sine and theta. Now comparing the real and imaginary part. So real part is Z cos and theta means Z transform. It is the bigger Z. Z transform of cos and theta is equals to this real part. And Z transform of sine and theta when we compare the imaginary part. So minus is here, minus is here. So that means simply this will equal to this. So Z sine theta Z square minus 2Z cos theta plus 1. So denominator is same in both of these expressions, right? Now this is your formula. This you have to remember, because if you are going to solve it, it will take time. So remember this. Okay. See here, this one, this one. Now damping rule again. You have Z cos and theta. See, remember here it is n theta sequence depending on n. Here it should not contain n, right? Z transform of cos and theta, we have the formula Z into Z minus cos theta over Z square minus 2Z cos theta plus 1. Now if it is multiplied by positive power of this, then Z will replace by Z by A. Wherever you find Z, just replace it by Z by A. So Z into Z minus cos theta a square. That means you will get a here, and z square minus 2za cos theta plus a square, LCM a square. So a square and a square cancel. That means this is equals to z into z minus a cos theta divided by z square minus 2za cos theta plus a square. So this is, similarly you can prove the last one. You have the z transform of sine and theta, and it is multiplied with positive power of a. So damping rule, this one. So next we have these IO homework, these questions. You need to complete this. Okay, I'll give you hint. You need to find z transform of n plus 1 whole square. That means rewrite this. A square plus b square plus 2n. Then use the formulas, right? Sin a plus b formula. Sin a cos b plus cos a sin b, right? So z transform of sin 3n cos 5 plus cos 3n sin 5. Now cos 5 will be treated as constant because it is independent of n. So cos 5 you can take outside, and z transform of sin 3n. Similarly sin 5 you can take common, means outside, and z transform of cos 3n. If it is not containing n, means it is constant. You need to be considered this as a constant. E power an. E power an means we know the z transform of a power n, z over z minus a. So here consider this as e power a power n, right? So a is this. So z over z minus e power a. That's it. Now you know the z transform of n, and because this is multiplied by positive power of a, where a is e power a, z over z minus 1 whole square it is. Now e power a power n into n. That means positive power of a, so here it will replace by z over e power a. This a, right? Cos hyperbolic and theta. I am writing the formula e power and theta now it's z transform. So you can take 1 by 2 outside, then z transform of e power n theta and z transform of e power minus n theta. You can solve easily. So please complete these questions. I have given you hint. You can do now. Now find the z transform of the following. Cos a plus b formula you can use in the like previous one. Cos a plus b means cos a cos b minus sin a sin b, the formula. Then use z transform. Very simple. Similarly here, because we do not have any formula for hyperbolic, so first write it in terms of exponential, then solve. See, cos hyperbolic n pi by 2 plus theta. Theta means here it is given as pi by 4. So consider this as theta. Exponential n pi by 2 plus theta means the whole this. E power theta plus e power minus theta divided by 2. That means this will be treated as constant, take outside, and z transform of this, z transform of this. Now whatever you want to use, you can use. Like z transform of a power n, you know, right? Z over z minus a. So here you can consider e power n pi by 2 as e power pi by 2 power n. means a power n, where a is this. So z over z minus a formula, that's it. It is very simple. Okay. Now once you find z transform, you can leave up to here. Combination function, z transform of NCP. Now you can use the formula because n is already included here. P is the variable. So we'll change this. Okay. Formula was n is equals to 0 to infinity un z power minus n, right? But n is already there and p is variable here, means sequence is depending on value of p, right? So we'll take summation p is equals to 0 to infinity un and z power minus p, where un is ncp. Okay, that means up you need to take. So expand this summation 1 plus nc1 z power minus 1, nc2 z power minus 2, ncn z power minus n. So this is nothing but exponential. One plus nx plus n into n minus 1 by 2 factorial x square, n into n minus 1 n minus 2 by 3 factorial x cube, right? Same 1, nc1 means n expanding 1 times. You know how to find, right? NCR formula. Factorial n over factorial n minus r into factorial r. So you will get like this only, n, simply n. Then you will get n into n minus 1. Okay, so using this, you will get 1 plus x power n. These two types are not that important. I will upload the slide and you can go through it. Not important. Okay, so I'll upload this material and you can go through it. Just you need to remember the binomial expansion and like how you can open this combination function. Okay. Now this one is important. We'll use in the difference equation. Like those who have attended today's class, I have told them in lab plus the shifting property, right? So in shifting property, this is not important. Only we'll use this one. Shifting to un to the left. Now, what is this? If z transform of un is uz, then z transform direct formula shifting k units n plus k. So whatever, how much I am like shifting this, it's k, right? So starting from k power, z power k, then uz minus u naught minus u1 by z minus u2 by z square, and it will go up to u power k minus 1, means u k minus 1 and z power k minus 1. Like if it is k, it will go up to k minus 1. So if you have un plus 1, right, that means k value is 1 here. So z power 1, capital uz. Now if it is k, it will go up to k minus 1. So k is 1 here, k minus 1 is u naught. So second value is u naught. This k is 1 here, it will go to k minus 1. K minus 1 means u naught. Now next is only two important. Z transform of u n plus 2. 2, k value is 2. So z square. It will go to z1. That's it. Okay. So this. You can remember up to un plus 2, or if it is 3, like if it is 3, so cube here and minus u2 over z square, one more term. Means remember this. Then you will be able to remember, you can find out un plus 1, un plus 3, un plus 2, like that. Okay, but not more than that. For example, z transform of 1 by n factorial is given, e power 1 by z. Like show that z transform of 1 by n factorial is e power z. Now we didn't read any formula regarding factorial, right? So we can use directly the definition. N is equals to 0 to infinity. Un is 1 by n factorial and 1 by z power n. So first term, n is equals to 0, 0 factorial 1, so 1. 1 factorial 1 by z, 1 by 2 factorial 1 by z square, 1 by 3 factorial 1 by z cube up to infinity. So you can see that this is the series of exponential with x is like e power x, 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. So here x is 1 by z. Okay, that means it is e power 1 by z. So proved. Now hence evaluate this. When it is writing hence evaluate, that means you need to use this to find this and this. Don't use definition. We need to use this. First we show this and we will find this. Okay. So let's find. Now un is 1 by n factorial. This un. We need to find un plus 1. Un plus 1 is nothing but n plus 1 factorial. When un is this, so un plus 1 is this, right? So z transform, and if un is this, uz is already we have found e power 1 by z. So z transform of un plus 1 is formula. K is 1, so z power 1. uz minus u naught. uz value is e power 1 by z. This is a small z only. U naught. If un is this, so u naught is 1 by 0 factorial, that is 1. So see, z transform of 1 by n plus 1 factorial is this. That's it. Now z transform of un plus 2, z square, uz, u naught, u1 by z. That means un plus 2 is nothing but 1 over n plus 2 factorial. Okay. Z square, uz is e power 1 by z, u naught is 1 and u1. So u1 putting n 1, so 1 factorial over 1, that means, so this is your value. Okay, so it's very simple to prove. Now multiplication by n, very important. If z transform of any sequence is uz, if this un is multiplied by some n, I'm talking about n. So if it is power 1, so we'll take minus z derivative with respect to derivative of uz with respect to z. Right? But if it is power more than 1, like power m, then minus z d by dz of power m and uz. So it's not like directly you will take, suppose you are multiplying by n square with un, that means minus z d by dz. Now this would be considered as operator only, not any term which is whose square is given. So this is differential operator. So it will be treated as, don't write minus z square, means don't write directly z square. So first operator means first will operate its first power to use it, means differentiate it then multiplied by minus z, then whatever the result you will get, differentiate it then multiply by minus z. Okay, this is an operator. See, nothing is given here whose differentiation, that means it is the operator form is given. Now see an example. Find the z transform of n sine n theta. See, multiplication by n. Z transform of sine and theta, you know, it was z sine theta, z square minus 2 z cos theta plus 1. Because it is multiplied by n, that means minus z d by dz of this z sine theta, z square minus 2 z cos theta plus 1. Take its derivative. Now you have to find its derivative. Denominator whole square, right? Then denominator same. Numerator derivative. Now derivative with respect to z. So theta will be treated as constant. Sine theta. Okay. Then z sine theta same and derivative of denominator, that means 2z minus 2 cos theta. Then solve this. Okay. You will get the answer. Now this z transform of n square e power n theta. So already there was unsolved problem, right? First way you can do like this. You should know the z transform of n square, z plus z square over z minus 1 whole cube, and it is multiplied by positive power of a, means e power theta power n. So we'll replace z by a, e power theta z over e power theta whole square, and so this is your answer. Another way is, we know e power n theta. E power n theta means e power theta power n, that means z over z minus e power theta. Okay, directly I have used z transform of a power n is z over z minus a. So here a is e power theta. Now because it is multiplied by n square, that means minus z d by dz power 2 and this. Okay, so I'll show here only. I'll not do the differentiation, but I'm just telling you. So minus z d by dz, 1 power, keep it like this, minus z d by dz of z into z minus e power theta. Differentiated this with respect to z, then multiply by minus z. The result you will get, again differentiate it and then multiply by minus z. You will get the answer. Okay, see here, minus z d by z, keep it outside, then minus z d by dz, differentiation of this, you'll get this. So after solving the differentiation, and multiply by minus z, you will get this. Again, take derivative and solve it. So it was about your shifting theorem and multiplication by n. In next class, we'll discuss more topics related to Z transform. Any doubts? Any doubts?
No, ma'am.
Okay. So tomorrow you have the quiz. I will quizzes for 10 minutes, but sometimes it take time to appear the quiz on assignment section. So I will set it for 15 minutes. And
Ma'am, can you please extend the time, ma'am?
no, 15 minutes are fine. And I'll not extend the time. If you are able to submit, then fine. If you are not, I will not extend the time because already I have faced in one class. If I am extending for even for a single person, so I face lot of trouble. Okay, so please don't ask to increase or to extend the time. I will give you sufficient time. I will not assign that hard question. Like within 2 minutes, you can solve the question if you know the concept. And if you are searching for the answer in your notebook or on internet, then it will take time. Okay?
Okay, ma'am. Okay.
It will be for 2 minutes, not more than that. But one thing, please don't ask to extend the time. Even I'll be offline tomorrow for half an hour. I'll not come even online to listen anybody's problem. Already I faced a lot. So I'll take your attendance.
Ma'am, exactly what time is it? 7 o'clock or 7:30?
It's 7:45, but I will set the time 7:40. So it take time to appear. Okay, so but you consider at 7:45. 7:45 to 8. Okay.
Okay, ma'am. Thank you.
Okay then. Mark your attendance, everybody.
Ma'am, 5 question or 10 question?
5 questions.
Okay.
So those who have marked their attendance, leave.